Hi, I'm here. Just sorting something out. That did not work. There you go. Starting on the Moodle page. You can hear me, right? We're going to wait for people to come in. I gave you no warning other than 10 minutes. So some people might come in, some people might not. There's 3 of you, so that's good. Let's see if people join us. Let's see what's happening when I do that. Okay. Still learning this, always learning something. Okay, so you guys viewing my Moodle page. Very good. So if you've gone onto the Moodle page, you'll see that it's a little chaotic. I haven't fully edited it yet. I was busy this week with many things, mostly setting up the program for the IMBA program. It's going to be the launch of a fully online program for the MBA. And anyway, you do have everything here on the Moodle page. It's just kind of extra things too, so I have to clean it up. What I want to do today is start with Unit 2. I guess I can ask you about Unit 1 and how far you got if you followed my directions. And you should have had access to the annotated lecture notes so you can see the answers to the questions posed in the lecture notes. You should have watched those videos that I asked you to watch. There's this homework you can do. You don't have to homework exercises. So if I open that up, it shows you the homework exercises for the first unit. So you can try these and see how you do. At the end are the answers. Not solutions, but the answers. If you want the solutions are all somewhere up here, I think. I put all the solutions. This you don't need. You guys are seeing my view. I put all the answers somewhere. Homework solutions, the very top here, you see? All homework exercises below are solved in this document. So when you open that, those are the worked out solutions to the homework. Oh, I don't start until GDS. Okay, so I don't start until the second. So you guys follow me? Let me go back. So that's here, right under course resources. Any questions? I have to keep talking or the video will buffer. Oh, it's following me. Okay, wait, I'll leave it like that. Okay. 17 people, great, welcome. All right, so I was just showing everyone how the solutions to all the homework exercises are here. Okay, so those are the worked out solution, whereas in the question paper, at the end of the paper, or the document, you do get the letter answers. But if you want the long solutions, those will be found in that homework document. So let me know, do you have any questions? Lots of clicking sounding. Hi, so yeah, if you can let me know you're here, so I have a record of you attending. Yeah, I'll need that just to fill the asistencia. They ask us to account for students, so I'll need that. So just, yeah, say hello. Okay, so stratified and multi-stage. All right, so I'll talk about that. Yeah, just let me know you're here and taking the course. And like I said, you don't have to be here, but you should send me, I guess, send me a message that you're not attending, but you're watching the video, so I know that you are still in the course. Okay? So hopefully you heard this message. Now this video should have the captions in it and the chat. Hopefully there aren't going to be no problems. Oh, look, I don't know. Did it turn off? Okay, it should be on. I hope it's on. YouTube changed how it does things, and we'll find out. Okay, so what the 30 plus activities? What 30 plus activities? I'm not sure. You mean the questions and the homework? What 30 plus activities? So here you have, you should be reading the lecture notes. You should watch the videos I mentioned, the videos that were the professional videos, and then my live stream videos that I asked you to watch last week, and then check the annotated notes. Then these homework exercises you can do. Then these practice assignments and solutions are just for you to review. And then there's these quizzes. So when you're done doing all these things, you can do the quizzes. And remember, you can do these as many times as you want. And in terms of grade, you only need to actually do one. Only one is going to count. Your highest grade on one of them will count towards your final grade. There's 8 sections, or 8, like there's 6 sections, sorry, there's 6 units in the course, but in 2 of the units there's 2 parts, so that makes 8 sections. So you need to answer 8 of these quizzes, 1 from each section, and then at least 2 others from all of the possible quizzes. So that makes 10. I think that's what I put in the prontuario. Let me verify what I just said. So in the prontuario, which is here, I know that it's a mess because they superimpose this template. I have to erase some of this stuff here. A little bit confusing. They being DASEP. DASEP is the continuing education department that's kind of taken over the platform. I'm saying kinda because I don't know all the details. Where am I going? I want to show you the prontuario, and I did edit this, I think. So let's see the prontuario. What did I say? What did I say? You should read it to make sure we're on the same page. So these are all the units, and you can use that list to review before the tests. See what I said here? Online quizzes will count towards your final grade. 8, with added criteria, the student must complete at least 1 quiz from each of the 8 topics. Well, now I said 10. Because I edited up here, but I didn't edit down there. So the total number of online quizzes that will count towards your final grade is actually 10. Is that what I put in? I'm sorry, it's just so long. At least one quiz from each of the 8 topics. I think I changed it to 8 to make it easier. Let me see if I put it here. So 1 from each, okay? Just do 1 from each. I didn't say care quizzes. So I double check if I said it. See, I said 10 here. Okay, otherwise I just said 8. So that makes it easier for you. So 1 from each unit, all right? 1 from each section. Calling them units. So I should edit that. I'm live streaming my correction. So this should say 8 here. So 1 from each. So usually I ask for 10. I'm making it easier on you. So you'll get the hang of it. I just erased the calendar. I had to put the calendar back and it'll make more sense. So each of these units, you see, so unit 1, D and S, you'd have to do 1 of these quizzes perfectly, would be nice. But you should try them all, okay? You should try them all and I'll use the highest score towards your final grade. Okay, so we're going to be here, except that somebody asked some questions, so let's see if I can answer the questions you have. That's what I'm here for. Let me see. Okay, Gabrielle asked about the 30 plus activities. I'm not sure what 30 plus activities mean. So you should do the homeworks. You know, the homeworks are for the homework and the practice assignments. That's all for you to review. Organize yourself to fit it in your schedule. Okay, so I'm going to talk about then. Let me see. I'm going to open the DNS unit and let's see about the difference between multi-stage and stratified sampling. It's a little bit of buffering going on. I'll go with these notes. Okay, so hopefully you read the notes and you were able to watch the videos because I assume that knowledge when I talk to you, okay? I assume that you've looked at this stuff and you know what? It's very common that students do not understand the difference between multi-stage and stratified, so that's why I'm answering the question. I went through all this. Sorry, I'm going to scroll. You see, these are the answers. These are the annotated notes. So there's the red is, those are the solutions. All right, here. So this was my example. I don't know if you watched. So there were the professional videos of the Decision Through Data series, and then there were my videos. And I don't know, I'm pretty sure I talked about this, but let's see. I'll talk about this again. So multi-stage and stratified were mentioned in the Decision Through Data videos. If you recall, they showed a map of the United States, and they were focused on a certain region, and they were saying, okay, we want to households in this region. So how are we going to do that? They mentioned some problems with the idea of just taking a random sample of people. So one problem was that they knew that people in the rural community were distinct from, in terms of, household income and characteristics. They knew that people in the rural communities are distinct from people in the urban communities. And then so also the people in the suburbs were different from the people in the urban communities and the rural communities. So they want to capture those differences. However, if you take a simple random sample, making a list of every single household, and then you randomly select, because a lot more people live in the city, you risk not having anybody from the rural community in your sample. So to correct for that problem, for underrepresentation, for problems of underrepresentation, you should use a stratified sample, okay? So that's when you might miss somebody. So this was my example about missing people. And remember, in the video they mentioned you should first divide the population into suburban, urban, or rural strata, and then sample within those strata. Okay, do you remember that? So that the problem was underrepresentation. So it's an issue of representation, to represent the characteristics that are different among these regions. So this solves the problem of underrepresentation. Multi-stage solves a different problem. However, it's often the case that surveys use both together, stratified and multi-stage. And that's what they mentioned in the video. So within each strata, then you can run a multi-stage sample. Okay? Let's see if you have questions, because I can only look at one screen at a time. Okay. Are you with me? Tell me you're with me. Hi, Freddie. Okay, so let me write some notes here just to summarize what I've said so far. So, stratification resolves problems of underrepresentation. I don't know if that's a word that I didn't say problems of representation. Okay. So to ensure the sample has people from all regions, the distinct regions are stratified. So it just means that sampling is done. You can hear my keyboard, hey? Sampling is done within the strata. Yeah, I was just writing and now I just pressed enter. So you should be able to see it now. I'm not writing it on the screen, just because I'm doing everything in Chrome right now. I didn't put up the PDF because I didn't plan to talk about this, but it's okay. Okay, so stratification resolves problems of representation. So to ensure the sample has people from all regions, for example, the distinct regions are stratified. That is, sampling is done within the strata. So the groups are divided, pre-divided, pre-sample, and then the sampling takes place. So what kind of sampling takes place? Now you could just take a simple random sample inside each of the strata. However, sometimes simple random samples are used, but sometimes multi-stage sample inside the strata is used. The strata are used. I think strata is a plural, just like data is a plural. So what's multi-stage? Well, let's start with the problem it resolves. Multi-stage, does anybody know in a few words, what does multi-stage sampling correct? Okay, Hector's asking if you have strata, do you have to equally sample from the strata? You don't have, no, okay, so that some strata will be smaller than others, right? So that's the whole point. Like if you have much smaller group of people in the rural community than in the urban communities, then you probably are just going to go by percentage. So maybe you'll get the same percentage representation, not exactly the same number, because you can't get the same number. So that's what I gave an example of in the multi-stage sample. So what is the, so that's my answer, Hector. So it's not going to be exactly the same number, but maybe roughly the same percentage. Okay, so if San Juan is urban, we sample 1% of San Juan, but then we go to Lares or we go to Utuado and we sample 1% of there. Okay, so what's about multi-stage? Okay, no, next, Jasmine, thank you for the response. It's a little more specific. So why would we use multi-stage? When you have a large group, what is the main motivator for multi-stage? Anyone? You can tell me if you can think it through. So stratification is for representation, so that each unique group is represented in our overall sample. Okay, you're getting closer. Okay, so it's going to be cheaper to do multi-stage, but why, Raphael? Why is it going to be cheaper? Okay, no answers. Okay. The issue that it resolves is okay, it resolves the problem of the cost, the expense of having to identify all households and label all households. So if you're talking about someone, and we're going to stratify within regions, let's say, so urban versus rural. So put all the kind of urban, so put like Ponce and San Juan together. with, what's another urban? I don't know if you consider Maya West urban, but anyway, okay, so you put those together and you say, okay, those are urban, and then more rural would be, you could pick a bunch of regions that are rural, and then in between, anyway, in Puerto Rico, we could divide downtown San Juan, which you guys don't even call it downtown, but like the center and then the suburb, like Guaynabo would be a suburb, I guess. Anyway, it's a little bit different in Puerto Rico, but the point is, those are the strata, but then within the strata, imagine in San Juan, Metro San Juan, finding an updated list of every household. Anybody who's been involved in trying to do such a thing, you're going to realize there's lots of transiency, people move, it's hard to get addresses and phone numbers to contact people because people move, there's lots of changes, 1 million people living in the metro area, right? And how many households is that? You'd have to figure it out, and then you'd have to keep that list up to date to the point that you randomly sample from it. So if you take a sample from all the households in San Juan, if you actually had an up-to-date list, that would just be a random, simple random sample. But in fact, it's hard to get an up-to-date list. So instead, you do something like look at the San Juan area and break it up into regions. And regions could be like the urbanizations, right? So you could break it up into Santurce, and then Atorrey, and what other ones? Guaynabo. So into these urbanizations, and then sample from those. So you make a list of all urbanizations in San Juan, I can't remember how many there are, and then you sample from that list. That way you avoid having to get the name, address of households in all of the San Juan metro area. So I just sample from those. Maybe it's not a good idea to do this in San Juan, but let's pretend it is. Let's say everybody living in these areas, it's pretty even. You have whatever you're looking for, what characteristics of the household you're interested in, you have the same variation in these different regions. So we first label those. So let's go to my example and I'll read through it, and you can think of that as the backdrop. Yeah, if you think about Puerto Rico, think about what you're interested in. What are the characteristics? If you think people who live on the west are distinct from people who live in the north, and they're distinct from people who live in the south, and they're different from the people who live in the east, that wouldn't be a bad idea, Jorge. You guys know better than me, okay? So if we divided them initially as strata, that's what you're talking about? Right, so let's say we thought that was a good strata, you could do that. But okay, so the next thing is to say within the strata, how are you going to sample? Are you just going to do a simple random sample? But then you run into the problem of making that list. Okay, so that list, the problem of the list is resolved by multi-stage sampling. So let's go through this example. This is an example. It doesn't have to be done exactly like this. This is just an example. How you might go about it. So say there's a budget to interview only 1,200 households in a country. So I'm going to do this in a country on their consumption of whole foods. So I want to look at fruits and vegetables, particularly distinct from refined or processed foods. So let's say in this country there's 18 million households in total. And I didn't use strata in this example, okay? But you can imagine we could do the same thing within a strata. So what you're going to do is identify the first stage. So in this country, it's easy to recognize regions. So you have a sample of regions. Say there are 30 identifiable regions. And you consulted with a sampling specialist and they determined that a third of the regions would be reasonable and representative of the country. So from this list of regions, you sample 1/3. So that means you have to label all the regions, so it's just 30. So you're going to label them with the labels 01, 02, all the way to 30. And then, let me write that down. So the labels would be I hope you know why I'm doing it like that. You guys know, right? Why am I labeling them with double-digit labels? Why am I labeling with double-digit labels? No one? Because the last one is 30 and labels have to have the same length. That's why the first one has to have a 0 in front of the 1. Okay? Okay? Alright, so then we continue. So we label the region 01, 02, all the way to 30, and then we use a random digits generator, and you pick the first 10. So now we have 10 regions. Now within the 10 regions, we go to the second stage. The second stage is some identifiable grouping within the region, and that could be communities. So let's say for simplification that every single region has 30 communities. Now that's obviously not realistic. They're going to have different sizes, but so what? It doesn't really matter. Just label them 01, 02, all the way to 30. And we consulted again, and the statistician who's a specialist in sampling told us 20% is enough. Now these numbers that I'm coming up with, these percentages, are going to depend on the variation. So there should be some sort of information about how much variation there is in the population. I'm not going to ask you guys to do this kind of thing, but at the end of the course, we're going to talk about sample size, like what is adequate sample size and some of the theoretical foundation for choosing sample size. But for now, I gave it to you, okay? So we sample 20%. 20% of 30 is 6, right? So we have to label every community and every region, 01, 02, all the way to 30. And then using a random digits generator, select 6. So it's 6 from 10 regions makes 60 communities we have so far. You with me? Next stage. Next stage is the next level. We're focusing in on closer and closer in on the households, right? That's where we're headed. So the next stage would be blocks. So each community has blocks. And let's say for simplicity that each community has 200 blocks. So 200, that's 3 digits. So we have to number 001, 002, right? All the way through to the last one, 200. And then we're told that it's going to be sufficient to sample 2%. 2% of 200 is 4. So you have to get 4 with a random digits table. Take 4 from the from the 60 communities. So 4 times 60 is 240 blocks. You see? Now, so far we haven't had to make any kind of list that was specifically targeting households. We avoided that. All we're going to do now is go to the level of households, say for simplicity there's 100 households on each block, and if it's not 100, we're still going to use a percentage, right? So we're going to sample 5% of the households on each block. There are 240 blocks. For each block, there's 100 households. So we're going to pick 5 from each block where there are 240 blocks, and there they are, 1,200 households. So what we have to do is only at this level, on 240 blocks, identify 100 households. So we went from 18 million households to just, what's 100 times 240? So that's 24,000. So from 18 million to 24,000 household labels, that's all we have to do. So we can find key people who are going to help do this in the municipality. It's going to help us identify those households, label them, and then we can choose from them and end up with 1,200 households. How's that explanation? Understand it better? So again, a lot of people have trouble with understanding the difference. I hope you can remember that difference. Yeah, you have to, the question of strata is a different problem than multi-stage. You can have both of them at the same time, but you have to answer those separately, okay? So you have to figure out if you're going to stratify at the region level or in some other way. Then once you have the strata figured out, then you can think, do you really need multi-stage? And if you don't have an active list or up-to-date list of households, you don't have access to that immediately, and it's going to waste a lot of money hiring people to figure that out or paying for proprietary information about that, then you're just going to do multi-stage and reduce the amount of work you have to do on getting that household information. Yes, Jasmine, you can do just you can do a multi-stage and forget about stratification if you don't need it, and you can do stratification and forget about multi-stage if you don't need it. But in large surveys like Census Bureau surveys, you use both. Very good. Okay, so that's all I'm going to say about that. Somebody else asked me about cluster versus systematic, right? I think that's what it is. Cluster versus systematic. Systematic and cluster samples. Yeah, I mentioned that in the practice. So systematic versus cluster samples. I don't expect you to know that for the class. That's something you can just look up online. It's like you guys can look that up. But systematic is where you choose, like you do kind of like a voluntary sample where you're just asking people as they, so if it's about people, you're sampling people as your subject, then you just pick, and you're sitting in a mall, and you pick every 5th person. That's a systematic approach. Cluster, now, see, I even have to remember what cluster is. Cluster is not, this is not something I focus on in the course. Right, so cluster uses some sort of characteristic to break up the population. So maybe in a mall situation, you're just going to focus on the people coming in, and you're going to focus on seniors. And then you're going to focus, so you're going to ask all the seniors who walk in, you're going to approach them with your survey question. Or you're going to focus on youth, and you're going to also look at them. So you're going to separate clusters out when approaching. Systematic is when you have like an interval. So every 5, you're going to ask a question. So you let somebody come in. I'm just trying to say, that those are different approaches and they have different rationales. and they have different estimates that go along. So all these different forms of sampling, when you have the data in the end and you combine them, you have to be wary of the technique you used, and it changes your estimators. So in this course, we're going to focus on simple random sampling, even though I talk about it, all these kinds of sampling techniques in the first unit, just to give you an idea. There's a lot of different ways to do things. We don't have time to review all those ways. You can take a lot of courses in sampling theory, but essentially, once you learn one kind of sampling, and you're good at statistics, the fundamentals, you can pick up and learn how to deal with other kind of sampling techniques and those estimates. Okay, so there's different estimators from different sampling techniques. We're going to focus on, after this unit, simple random sampling. And we're going to build our theory with simple random sampling. And then, like I said, if you're going to use some other technique in the future, you'd have to be wary of your estimators and account for the way you did things in creating your estimates, or at least to explain any curiosities of your data, your outcomes, your measures. Okay, so the other thing, any questions about that? I'm just giving you an example. Okay, so systematic would be sample every fourth unit or subject, for example, and cluster would be sample based on some characteristic. So you say, okay, everybody who has, let's say, a pre-existing condition, contact this number, we want to sample these people. We were interested in a sample from this cohort. Okay. Just another point. You could just use the techniques of estimation that we're using, but you'd have to count, like I said, you'd have to account for any surprises or anomalies or your results. You have to explain which sampling technique you used so that people could consider, critically analyze your results, saying, okay, well, maybe you missed this because you used this sampling technique, for instance. Okay, so you just got to be transparent about your sampling technique when you report your results. Okay, so that was almost an hour talking about this. So there was another question about bias, upward and downward bias. Let's see, what is the problem there? Let's be more specific. I think there was some. So you should have the feel that depending how you phrase the bias, you can refer to it as upward or downward. Okay, it's a matter of how you phrase the phenomena. So again, to understand these nodes, you have to watch the videos. Okay, you need to watch the decision through data videos, and then you'll have a better idea of what's going on here. Otherwise, you're missing. You have a huge gap in your understanding. So make sure you watch. It's an hour's worth of videos. I saw a lot of views. Seems like a lot of you watched them. I don't know that everyone did though. So these are my examples. Do you have a direct question about that? Whoever asked that question. Okay, Jorge, explain. So political surveys of El Nuevo Dia, how are those biased? Upward or downward? So it depends how you say it, right? So it's, how do you think El Nuevo Dia surveys are biased? Make a statement, Jorge. Someone else, if you like, make a statement. Using the term upward or downward bias. I'm waiting. I'm waiting. So let's see. Oh. Okay, so newspaper surveys are biased, or online, let's make a general statement. Online surveys are biased towards the opinion of people with the means to own a computer and have internet access. So it's upward bias. Depends how you state what characteristic of it. You guys still didn't give me a sentence with upward or downward bias. Someone give me a sentence with upward or downward bias. I mean, it's easier for me because I don't know. But downward bias towards what? Like what? Like you have to say what? Like downward bias, the percentage is low. On what topic? Like you have to be more explicit, Hector, who's actually wrote something. You guys are still not making the sentence with the word. So use the words upward bias or downward bias. And again, this is something students do struggle with. Just make a sentence. Aha, excellent, Edgar. So polls are upward bias, showing results favoring new parties rather than traditional parties. So, so upward bias there. Yes. Upward bias, higher percentage of respondents. So upward bias means a higher percentage than it should be. Favoring new rather than traditional parties. Very good. Very good. And very good. So now do downward bias. you can do the same thing. You can just flip the subject. You can now say, you can do the same sentence, but now talk about the older population. Or senior population. Okay, I see what you're getting at, Elena. Let's see if I can make it a little clearer. Yes, that would be downward bias. So less asking only seniors with downward bias the outcome of surveys or polls. Or election polls. To Okay, so asking only seniors would downward bias the outcome of election polls to determine if newer parties have any chance in upcoming elections. So if they ask a question, what's the they just focused on seniors, so they went, I don't know, they identified seniors somehow, maybe through, it's hard now, right? Because we're in the pandemic and people don't go to the usual places that they go. But maybe through people just registered in the parties. If they just ask people who are registered, or they ask people, seniors, because usually you identify seniors early in the morning, and they're up and at the malls, and they're in Home Depot, right? Seniors are more active in the morning, and you can find them if you want to approach them. If you want to contact them, you have information. Maybe from certain outlets that deal with seniors. I'm trying to think. So you have some sort of way to contact just seniors, and you ask them this question about what they think of the new parties, and it's going to look bad. It's going to be low. Those numbers are downward bias. They don't reflect the whole population. It just reflects them, right? So you have to be careful about who's been asked these questions. And Elena said something down towards low-income women. I think what you're trying to say is if you ask women about access to health care, and you only ask low-income people, it will be a downward bias. It wouldn't be representative of the whole population of women. So it's an issue of a bias created by asking a certain sector, not the others. No, okay, so probably women's access to healthcare is going to be high if they're asking internet users who are all savvy and they know how to get what they need. So it would probably be upward bias, incorrectly upward bias. Okay, it would be upward bias, and it's ignoring a segment, and that's going to upward bias the result. Exactly. So you're going to think of the sample, the people who were asked, and how that affect the outcome. And it's not representative of the whole. It's just one segment of the population. Very good. Okay, good. All right, I think we're better. So let's see if we can go on now. Let's look at Unit 2. I want to just start you on Unit 2 because, in fact, you have all these videos to watch on Unit 2 that I've listed here. Let me make it much more clear. So you see, so that's Unit 1. So work through that stuff. Remembering our first test is not until, did I put it here? September 26th. So we have lots of time. We have lots of time. Well, I'm saying that, and then the time's going to creep up on us. But we have a few weeks. And first test is going to be just Units 1 and 2. So you guys got to be good at this stuff. And what I'm going to say is work through all of these, and then you move into Unit 2, which has the lecture notes, the annotated notes. This sample problems goes with the lecture notes, and I'll show you how. Then the homework, like you had for the first unit. And you have all of these. Look at all these videos. These are all videos. Look at all the pages. 8, 9, 10. It's a little bit gap here. 14, 15, 16, 17, 18. Like almost all the pages of your notes. 23, 24. And these are edited videos. So these are, these took me forever to make. I'm not going to say like they're highest quality professional videos. You hear Cookie in the back. But they're all thought through. And I didn't have a script, but I retaped and retaped to get these right. So these are your best resource, okay, for this material, 26, 27, 29. So what I'm going to do today is introduce this unit, get you started, and then I'm going to leave you with these videos to watch. I added up the total of all the videos here, and it was like 7 hours for all the videos in the whole module, the whole Moodle page. I don't know if I added up just these, but it's a few hours of viewing, I think. And you might want to rewind, so it might take you longer. Then I have some homework exercises I worked out. And again, practice, 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 quizzes. Oh, and then I have some quiz examples here. So all these quizzes, I'm not giving you guys quizzes in this course, except for the online quizzes. So you should take advantage. I'm going to move these up here so you don't confuse these. If I can move, it's not moving. So these are the online quizzes here, and these are just PDFs. I'm going to move it so you guys can see how I do things here. I'm going to move this up. It's kind of buffering. I'm sorry if your screen is buffering. Let me know if you got buffering or it's a smooth live stream. I don't know what's happening. Oh, I took the wrong thing. Oh, these are all moved around now. Okay, I'll have to do this another time because it's buffering. So these are just questions and solutions from in-class quizzes. Let me show you what that looked like. So at the beginning of class, I would give students a question paper and they would have to solve it. So you guys can try that for practice. And I think I have the solution right here. See? So you should try it on your own and then check the solution. Don't just read the solutions. You won't appreciate them. I won't appreciate them as much. There, I moved it. So these are different than the green. The green ones are the online quizzes. Let me show you those. You see, it's just so unstable. Okay, so these online quizzes, let's have a look. So you get 40 minutes to do this. And this is my attempt. And then you see the questions? Oh, I already know. Oh, this is I have to hear first. This is the honor code. So by beginning this quiz, you agree to this, okay? And then here are your questions and the options that you have. Questions and the options, question, yeah. Once you submit it, you will see if you got it correct or incorrect. Let's see what happens. Let me just select whatever. And then I submit. Okay, it's asking me a million times, did you get it? So it tells me if I got it wrong or right. So that one was wrong, this one was right, wrong, and wrong. So then I can try it again. I say, end this review, and then I can try it again. So however you want to use that, I think you should use it by testing yourself and then like really trying hard the first round and then identifying where you have problems and solve it and then go again. Remember, you only have 40 minutes. Okay? Let me go back to the course. Okay, so I said I want to begin with the lecture notes for GDS and the sample problems. So open those up. So at this point you should have had the chance to get a calculator, and the videos will review how to use the calculator. I think in the videos I use the XA calculator, so I'm going to show you how to use the TI, the BA2 Plus today. Those are the two things I want to do. I want to introduce the GDS unit, and I want to show you how to use the calculator. Because like I said, the edited videos use the other calculator, which is fine if you have that, but I need to show you how to use the BA2 Plus, which I really emphasized I wanted you to get. So let me close these windows. Let me check if you have any questions. Yes, unlimited amount of attempts. Did I mess up the date? Let me see. September 24. Yeah, we have good time. Let me see about the date. it should be the 24. I think somebody wrote me about that. I thought I fixed it. So this should be 24. And it's only 10%, so I'm giving you guys time. You got to catch up. You know, once the test is done, don't stop studying that material. So for that test on the 24th, what did I have? What do I have in the promptuario? Do I have the 24th? Probably not. No. So I'd have to fix this too. So it's the 24th, it's the Thursday. Yeah, I want to make it in the class time, the first hour and a half. And if we decide to continue the lecture, we'll continue after that. Okay, so for that test, it's going to be the DNS, the GDS, and normal distribution. And you notice here, this is the normal distribution has also most of the pages here. And I'll do some review. So for now, let's open up the documents, or look at if you printed them, open up this lecture notes and sample problems, okay? Okay, give me 5 minutes. You guys, if you need to take a break, I'm gonna just set things up. So let's just take 5 minutes and have a bit of a break. Okay, that was more like a 10-minute break, but I'm back. You should have these documents in front of you or available to you. And I'm going to start, well, I'm going to flip between them. I never figured out how to do this properly, but I'm going to flip between these documents. So that's this one, and then and this one. Okay, one says sample problems, and the other one refers to the notes. I can actually put them side by side. Okay. Okay, you with me? You got those? All right. So, Unit 1, how we've covered it, and it was all about data collection, collecting data and how to do it well for both experiments and for surveys. So let's now presume we have the data and we're interested in answering a question which, motivated the data collection. Now we're going to answer the questions, okay? And so I'm going to give you a bunch of different data sets. So in this, these are the notes, like I said, we're going to go through, but I'm also going to refer you to these samples, the examples here in sample problems. These examples, there are 4 of them. First, it's Maris and Ruth. Second, the spending data. Third, Newcomb's data. And fourth is hot dog data. All the data is here. Okay, so it's available to you. And then I have some outputs I create here. So these are our graphs of the data. And then what I do, so these are all the different graphs for the 4 data sets, and I discuss through my videos each one of these at some point. And if I don't discuss it, it's written about in the notes. And what's the goal? So first, notice there's a number 2 here. Oh, I see you guys are not seeing me move the screen. Okay, wait. Oh no, it's moving along. Okay. So you notice here the heading is number 2. Statistical summary. It's number 2 because the previous heading up at the top, the previous heading after I introduced those was number 1. So I want to emphasize, first, you make a graph. You visualize your data. Second, based on the graph, you compute statistics. Okay? So first you make a graph. So let's look. The first data set I want to talk about is this one, the spending data. Here's the spending data. What is the spending data? So now that I've shown you that, I'm going to flip back to the notes for a moment. to discuss the spending data, but I wanted to link them for you, okay? So it's the second exercise in the sample problems, but it's the first in the notes. Got it? So now I'm going to go to the notes. So here's page 2 of the notes. I'll give you a moment to find that. And see if you have any questions. Everybody's good? Everyone sees that? Let me make sure it's feeding into the video. Oh, I see it on mine, but let's see. Yeah, you see it. Very good. Okay, so this is the spending data. A marketing consultant observed 50 consecutive shoppers at a grocery store. And the questions are, how much do shoppers spend in the store? And 2, how can the data help improve the store's marketing strategy? So looking at this data, I put it in order. These are not order of occurrence. These are by order, in numerical order. Okay, that's how they have been presented. So in numerical order, the first person recorded spent $2.30, not the first person. Some person spent $2.32, and that was the least amount, the least spent in the store. Some other person spent $6.61, and that was a little bit more. Okay, so I put them in, I've ranked them, I've ordered them to facilitate this demonstration. So you would rank them first. So you put them in some sort of order. By doing this, I can present the greater pattern. Okay, so the goal of presenting or visualizing the data is to group together and count how many observations are in each group. So grouping the data how? Well, similar numbers will be grouped together, and we can say so many of them were low, some of them were higher, some of them were even higher, and some were really high. This is a distribution. We're going to present a distribution which shows the values and that the variable takes on and how often it takes those values. So to get a general pattern, we have to abstract away from all this detail. One of the points of detail are these decimals, like the cents spent. It's too much detail for what we want to look at. We want to be able to group these numbers together. So I'm going to suggest that this is a good representation of the data. This is called a stem and leaf plot. Now, some of you might have seen this before, you're familiar with it, others have not. I want to give you a moment to stare at the stem and leaf plot and stare at the data and tell me where it comes from. How did I draw this? And give it a little bit of time. Let some people who've not seen this before think about it so they can appreciate the answer. So how did I come up with this visualization? What is going on here? In other words, what's a stem and what's a leaf? Oh, my screen went black. Why did that happen? So any comments so far? How did I make this graph? What are stems and what are leaves? Very good. Okay, Liana and Hector, very good. Okay, let's see. Okay, so the first value, okay, you guys are getting it. So let me show you. The first number was $2.32. Right? But it shows 0, 2 here. The 32 is missing, and there's a 0 in front. So let's look at the highest number. The highest number is 69, right? So it means that the highest number has 2 digits. So all of the numbers represented by the stem and leaf need to have 2 digits. So the highest number, the last one, is here, the bottom, 69. So that's pretty clear. So you see that the first digit, or the ones, is going to be a leaf, and the tens, in the first, how do I say this? Yes, and then this is going to represent the 60. Okay, so that's the first digit, this is the second digit, or this is in the ones column, this is in the tens, if you know what I mean. So what's going on? What's going on is we are creating classes. And the first class goes from $0 to $04. So all the numbers, all the spending between $0 and $4 goes in the first row. In the second row will be spending between $5 and $9. You see? So I have to use 2 digits again because the largest number has 2 digits. So because I want to keep the same digits all the way down to make this graph, feels like what we did when we did labeling. That's why the first one has to have a 0. And I start at 0 because it's sensible to start at 0. Somebody could go to the store and not spend anything, right? So I'm going to use the interval 0, 0 to 0, 4, and then go to 0, 5, so there's no overlap. Then the next one will be 10 to 14. So why I do this, let's see if I can put it a little bit closer. So it's aligned. So why I do this is so that the first digit is the same for all the values that fall in this row. Lots of clicking. I'm going to have to get my other pad for doing this. Okay, oh no, that didn't work. So, yeah, that's not working. Okay, so the 0, 2, that's the only result that falls in this class. In the next class, we have 0, 7, So they all share the 0. 0, 7, 0, 7, 0, 8, 0, 9. So the first digit is common to all of these here. Now when we get to 1, the first digit is common to all of these. 10, 11, 12, 13, 13, 14, 14, 14. Okay? And then for the next class, again, the first digit is always the same. So from 15 to 19, they all have a 1 in front. So they can share the same stem. Got it? Now that doesn't explain what happened to the 32 cents. So let's talk about that. Let's see if you have any questions first. Right, so everything was rounded. It was decided that, before I made this, I decided that the decimals add too much detail. I don't need that much detail. So the numbers were rounded. So the data was rounded. Whatever you do to one, you have to do to all of the data, right? You have to be treated the same because each data point is just as important as the other data point in the way that I've done this. Okay, so all the numbers now from $0 spent to $4 spent are all treated like the same. They fall into the same class. And all the numbers from 0.5 to 0.9 are treated the same. They all fall in the same class. And all the numbers 10 to 14 are like the same, and they all fall in the same class. You see? So let's see, for the 2 was 232 and it ends up being a 2. So the next one was 7. Let's go back and see what we did. So 661 became 7. And $6.90 becomes also 7. And 804 becomes 8. Now when you have a lot of data and a lot of variation here, those decimals just don't matter. I capture the pattern of the data well enough. Now how do I know I caught the pattern of the data well enough? Well, I'm going to talk about that. Okay, we're going to talk about that. First of all though, I am going to ask you if you have any questions of what I've done so far. If I give you a question on drawing or sketching, usually I'll give you instructions, okay? I won't expect you to make, in this class, I won't expect you to make all the decisions about how to draw it, but I could ask you to show me all the ways to draw it, or something like very direct questions, which I will discuss. So this is called a split stem and leaf plot, because I went by 5, intervals of 5, 0 to 4, 5 to 9. I went by 5 and not the customary 10. So I use this word split. We use the word split. If it's not let me say, make a note here. So if I went by 10, that wouldn't be considered split. That would just be a stem and leaf plot. Okay. Now, stem and leaf plots can get very complex, and I'm not going to get into so much of the complexity. I just want you to understand some of the basic, if for instance, if you asked a computer software to make you a stem and leaf plot, it might make it in a way that surprises you, and you have to understand how to interpret that and what it's doing. But it's choosing the plot that shows the regularities as well as the curiosity. So what's the regularity? Where is the pattern here? Pattern is that most of the data are here. And then what happens is, can you guys see my drawing? Let me make sure you can see that. Yes. So most of the data is over there with the low values, and then there's a few observations in the tail, we say. Yeah, and Leanne is asking a good question. I mean, all questions are supposed to be good questions, right? It's a really good question that if you had a smaller sample, would you have to use the decimals? It's not about it being a small sample. It's about it being a variable sample. So if you had numbers, like if all the numbers look the same and you had no variation, so for instance, if you had So if you have numbers like 1.02, 1.08, 1.19, 2.01, like they're all very similar, you're going to want to keep the decimal places, okay? So it's the variability. That's what you want to capture. So it's about them, whether they're the same or different, you want to capture. You don't want them to be all different. If there's all different, then there's no pattern, right? Okay, so all right, so we have talked about the classes, we've talked about the pattern, and now what we do is we use a systematic approach to summarizing the data set. We're going to summarize this distribution. So this is called a distribution. When I smooth it like this, when I put that smooth curve around it, what I'm saying if I had all the data, like if I had the population, I believe if I had all the data, I believe the pattern would be like this. So more data would reinforce the pattern the red pattern that I've drawn. And usually, you know, even though I've drawn it like this, going vertical, what happens is that we would flip this horizontal. So I would draw it horizontally for you, okay? But anyway, you get the point. So we're going to comment now where we know there's values underneath this curve. This curve is called the density curve. I'm going to tell you right off the bat, this is like the density curve. This is what I believe. This is what I believe. If I had more observations, I believe the pattern would be sustained. Okay, so that's what I'm saying when I smooth it out. That's what I'm implying. And now what I want to do is, based on this, I want to summarize, now that I have my graph. So part one, is the graphical representation, and then part 2, based on the graph, present a statistical summary. Okay. The statistical summary that I'm going to teach you, a systematic way to do this, is the 5 features of the distribution. Okay, the 5 features of the distribution. What are the 5 features? So let's work through it together. First, we comment on the shape. The shape is either symmetric or it's skewed. Symmetric is a pattern that you're familiar with if you've taken stats or if you just know what symmetric means. Symmetric looks like this, or like this. And that's not exactly. Okay, that's not perfectly symmetric. So 2 humps that look the same. Imagine that that's symmetric. Okay, so those would be symmetric. Roughly symmetric. Okay, so the idea of symmetric is that you can imagine I can cut the data in half and what's on one side is on the other. Okay, so these would be symmetric over here. This one and this one. So if I cut it in half, you see what you see on one side, roughly you see on the other. When you have this drawing that we've made here, and this drawing, you see most of the data on one side and you see a few observations on the other. When there's a few observations in the high digits, we refer to this as a right skewed distribution. This is right skewed because the tail is in the high numbers. So you imagine a number line and that this number line goes from small to big on the right. So this is right skewed or right tailed. In this unit, we refer to it mostly as right skewed. Okay, so that's how you would comment on the shape. Got it? Yeah, Leanne is asking me about the bell curve. That's part of it, but those obviously the bell curve is not the second one, right, that I drew? So symmetric, so a bell curve is symmetric, but symmetrics are not necessarily bell curves. Okay. Okay, so that's the shape. So that's the first feature. The second feature, based on the shape, what is the center of the distribution? Center, or another word for that is expected value. So think about it this way. If you were to bet, if you were an employee or the statistician that was hired or the student who was hired to do this project at the grocery store, and you were sitting back and you had all this information, and you were to place a bet with the manager and say, okay, how much do you think that next customer in line is going to spend? Or the next customer that walked in the store? What you're asking for is the expected value. Okay, so what would you bet on? So looking at this data here, what would you guys bet on? What is the expected value? $15, okay. Between 10 and 20, okay. Who else? I'm just saying okay, I'm not saying it's right. I'm accepting your offer. Anybody else? No idea? I lost the feed. What do I need to do? What do I need to do? It's telling me excellent connection. You know what I think happens is I think that YouTube cuts me off at 2 hours. Anyway, we'll see what happens. Okay, so Hector, 20 or 21, okay. It's still blurry. Why is it blurry? I don't know how to unblur it. See if I just go off and come back on. Why is it doing that? I was just admiring how nice the video looked. Okay, let me post this video. I'm gonna stop it and then open another one, okay? So we're gonna have another 5-minute break. Okay, let's break here and you guys think about that question, okay? I'll get back to you. Okay, I didn't get out. All I did was refresh. So if you have a blurry screen, just refresh your screen. If you have a blurry view, just refresh the page. And we can continue. Let me know if that works. Maybe you didn't even see it blurry. Mine was blurry. Let me know if that works. Okay, good. All right, so back to the question. Well, should I give you the 5 minutes? Maybe some people left. Okay. Okay, let's just have a couple of minutes break, okay? Just 2 minute break. 2 more minutes. Just so if people left, they'll come back. Okay, you guys are giving me a bunch of good options. You are giving me a range of values, which is also interesting. Okay, so Hector says he's going towards 21. That's good. Okay, so let's see. What is my response to this? So people who chose around here, the peak, so this would be what I would call, this is called the modal class. This is the class with most observations in it. So if you pick somewhere, if you said 15 to 19, then you're picking the mode, what's called the mode or the modal class. All right. People who chose, let me see what other things you guys chose. Some people said to 21. Okay, so somebody who chose over here, so from 20 to 24, this is where I think we're going to find them, what's called the median. And then what's missing? So we have the mode and we have where the median is. How do I know that's the median? Does anybody know what the median is? What's the median? Okay, the median is the middle number, a center number. Okay, so that's good. So the median, to find the median, what you do is you look at how many you've got. You have 50 observations, right? And we want the middle number. So the median okay, so median is where the n plus 1 over 2 observation is. So that's 51 divided by 2, or 25 and a half. In this case, it's the average of the 25th and the 26th observation. So we got to find it. So what we do is in the ordered data, we count Now we don't count from the graph, okay? We count from the ordered data. And see what I've done is I've numbered all the observations for you. Not in order, but in rank order. This is the rank ordered data. All right? So all the observations are numbered. So what I'm saying is between the 25th, which is this one, here, and the 26th. Which is here. I can't get it. Okay, so averaging those, that would give you the middle number. Notice the median is not necessarily an observation. It's just the center of the data. Got it? So what would that average number be? Well, I shouldn't put it there yet. We have to discuss which one is the actual best one. Okay. So what would that number be? Did you calculate it? What's the median? I'm going to erase some stuff here. Get this out of the way. Oops. Can I move this down? Oh, I don't know where to move this. I'm going to just delete it. What'd you guys get? Let's see. 20.735. Okay, so remember the first couple of things, the things to notice here is I went to the original data. Okay, you have to go to the original data. Don't go to the graph because remember we rounded and we manipulated the numbers. We want to go to the original data and calculate it, and we find out it is, we could just round. We can just say in the end 21, but my rule in the notes, if you read the notes, is when you make calculations, keep 2 more decimals than the original numbers. So that's what I'm going to do to maintain consistency. So when you do average these numbers, 20.58 and 20.89, $20.735, so I'll keep all of those digits. And that must fall in this one here. Okay, so the median ends up being 20.735. So yeah, you'll see in my notes I explain that the rule I want to use is that you keep 2 more decimal places in the original numbers. Okay, so then you can get the numbers I get. It's not wrong. If you said 21, I would be fine with that unless I was strict about the rule. I'm just telling you the rule I use to have consistent results in my notes. So if you want to reproduce my notes, you use that rule. Okay, so 20.735 is the median. And then, okay, so we have so far, I have calculated the modal class. So I'm saying this is like the mode in here. So mode is usually the most frequent observation, but because I divided the data into classes, I'm going to go with the modal class. So the modal class is 15 to 19. The median is 20.735. And what's missing? What's another measure of center we could have used? So we have mode as 1, 2 as the median, and the other one is, some people told me, the average, right? So the average I haven't talked about yet. So where's the average? What is the average? How do we calculate the average? Is it going to be the same or different? I guess that's the basic question. Is the average the same as the mode or the median? Yes or no? That's right, no. When data are skewed, so you won't find the mean in the modal class, and it's going to be different from the median when the data is skewed or are skewed, okay? But just for exercise, let's calculate the mean together. How will we calculate the mean of the data? And where, well, this first question, where is the mean of the data? Approximately, without making a calculation, where's the mean of the data? How would we know that just by looking at the distribution? How would we know the mean of the data? Okay, so yeah, you could add up all the values and divide by 50. You can't see what I wrote there. Let me put that in. Oh, I know what I'll do. Go like this. Just looking at it. I don't need to get the exact calculation, but just looking at it, how will I know where the mean is? I want this, okay. So the way that I know where the mean is, this is the discussion here. It turns out that adding the numbers and dividing by how many there are will give you the center of the distribution, the center of gravity of the distribution. All right, so it's the balancing point of the weight on each side. The density or the weight of each side will be balanced by the mean that will be here. All right? So this weight, this density, like this area, okay, you think about this as a mass, and this weight, you guys can read my writing. I should stick with the typewriter. They'll be balanced off right here. Now notice, it can't be the mode. Mode is not going to work, okay? And it can't be too far away in the tail. It's got to be just right. Got it? So now going back to our graph, Where would that be approximately, looking here? Where would this balance? Which class? So let's do you have a rough idea that it should be let's ask the question like this. In relation to the median, where's the mean? Let's ask like that. Let's see if 5 of you respond. Okay, Jasmine, thank you. Who else? Hector, above the median. Okay, who else? Okay, the median would be higher than the median. The mean would be higher than the median. Okay, so 3 of you have said that and you are correct. The median, let's be more specific, okay? Because you want to deal with left skewed as well at some point. So you want to be able to answer this more in general. As it turns out, let's think about the way, let me go back. Let's think about the way we calculated the median. What numbers did we use to calculate the median? What observations did we use to calculate the median? We used the 25th and the 26th observations. We used 2 values in the middle. In other words, values in the middle were used to calculate the median, not extreme values, okay? Just 2 values in the middle. So the median is not sensitive to the high values over here. It wasn't sensitive to the high extreme values over here. But what is sensitive to the high values over here? I'm trying to mark it. I can't. To the high values over here, right? What is sensitive to that is the mean. The mean is going to be affected by the high values because the mean uses all the numbers. So the mean will always be closer to the tail than the median. Got it? And so if it's left skewed, if the skew goes the other way, then you can answer the question without problems. Okay, it's going to be closer to the median, closer to the tail than the median. So in this case, it's going to be higher. Got it? All right, so we have 3 numbers, the mode, the median, and the mean. Which one is the right one we should bet on? The next customer coming in, how much will they spend? We didn't even calculate the average yet, but let's see if we need to. So which one do you guys pick? The mode, the median, or the mean? Okay, someone says the mean. Place your bets. The median with a question mark. Keep going. Median Hector with no question mark. Okay. Mean Jasmine. Oh, it's split, hey? I know. So you got all of them. Okay, good. Okay, so you have 3 to choose from. Thank you all for your suggestions or for your answers, for your honesty. What we're going to do is say, this is what we do in statistics, is say, look, we have 3 to choose from. We have the mode that represents the most frequent class. We have the mean that includes those very few extreme values, and then we have the median in the middle. Depending on the data set, if it's skewed, the median might fall in the modal class, it might not. If they're different, you should pick the median. In this case, they're different. We found the median is, so the class for the median is different from the modal class. So we're going to pick the median because they're not the same, they don't overlap, and we have to choose, from the 3 of them. So if they're different, we have to be very explicit which one to take. The median is in the middle of the mode and the mean. The mean we don't like because the mean it's only a few values, and it ignores, it's closer to only these few extreme values, and it ignores all of this data up here at the top, at the lower numbers. So that's not going to be good. So if the numbers are vary between the mode, the median, and the mean, we pick the median, okay? We pick the median. That's what we bet on. So the expected value, the center of the data, is median for skewed distribution. And we already calculated it. All right, so there's 3 values to choose from. We know their order. We know the mode is below the median and the median is below the mean. If they're all distinct, we should pick the median in the middle of those. That's how we're dealing with this. All right? We're not going to be influenced just by a few extreme values. Any questions? So now you know. Even though we did do that, I want to take a moment to show you on your calculator how to calculate the mean. And I'm going to prove it's a different number than the median. That was 20.735. Actually, it's in dollars, so let me put a dollar sign on it. We should always keep our units, right? And put a dollar sign on it. All right. So how do we calculate the mean? Let's go. There are a lot of numbers though. So let's see who gets it first. Oh man, this is going to be tough. So for calculating statistics, remember you have to go to the original data. Now you can do this in Excel. It's fine to use Excel. There's a lot of numbers here, but let me just show you to start, and then you guys I'll leave it as homework. I'm going to show you with my calculator. This is the BA2 Plus. hopefully I can do it. Because my signal is not so strong. Okay, let's see. I can do this calculator. You guys see my calculator? Okay, let's do this quickly because I don't want my signal to affect things. Okay, so I'm going to make this a bit smaller. I have to position these things. Okay, so this is my BA2 plus. And what I want to do on my calculator, if you have yours, is turn my calculator worksheet on. Second data will do that. So do I have to give you a moment to get your calculators? Let me know. Now, you know, this is a distance class as far as I'm concerned. You guys can use whatever you want, but I'm going to provide instructions with this calculator. And again, it's a finance calculator. It'll be useful to you. This is going to be of great utilization in regression when we get to regression. So I recommend you follow along. So I'm going to enter the data through here as $2.32, enter, and then I hit the arrow down. It tells me why. Why would be if I had pairs of data, like two variables, but I'm only doing one variable, so I ignore that. I just hit the arrow key again. And I go to the second data point. So the next one is $6.61. Enter, down, and I go down again just because we have no y. And then for the third, it's $6.90. Enter, down, down. And then $8.04. Enter, down, down. $9.45. And I'm thinking I should have done this before and had it all here. Okay, so that's how you do that. Now let's say I had everything entered, and I'm not, because there's 50 and I'm not going to keep going. I hit second. To get the results, I hit stat. Did you see that? Second, stat, or statistics. Does it show up above the 8? Oh, I think it froze. It froze. Okay, let me do this again. I'm going to reboot the phone. This is just an issue of my connection. Usually I forgot to turn on my Wi-Fi that's closest to me. Oh, sorry, I'm going the wrong place. It'll show up again. There's lots of signals. It's not connecting. Come on. Oh well, that's not working. Okay, well, I'll just tell you what to do. Just wonder if it has to be. I'm here just trying to sort this out. I don't like giving up, but I don't like wasting time either. Okay. It's like I said, I got to do this fast because the connection's going to break. Okay, so I entered, what I did was, no, it's not there, okay. So what I did was I used second data to enter all the data. And the way that I entered that, no, it froze again. Still keeps on freezing. Okay. Skip that. I don't know why. Okay, I'm giving up. I'm giving up on this. But let me leave the phone up, or the so what you're going to hit is what you're going to use is second data. Man, it's just all jumping around. Don't even know what it's doing. Okay, it worked somehow. The second data, and you see I've entered the values, and with the arrow key, you see I've put everything in. The way I put everything in was by putting the number. Let's see if I can. I've entered up to 5, 6. Let's put in 7. 7 is 1134. 1134. Enter. Down. And now it says Y. Now I don't have a second variable, right? This is only one variable, or univariable analysis. So I just go down again. Now the 8th one is 1163. Enter and down. And I continue like that, okay? I enter all the values. So let's pretend I entered all the values. Then I hit second and the word stat, which is above the 8. And it shows me the results. You're still seeing the 0 screen, hey? Are you seeing something different? Okay, so now I'm going to, this lin stands for linear. Okay, so these are the linear results. If I had pairs of data, I would be making a line. You'll understand that if you don't know already what I'm talking about. So what I want to do now is, using the arrow, scroll through the results. So first it shows you that there are 8 observations so far. And if I keep going down, it shows me the mean. So X bar is a symbol for the mean, or average. And so far I've got $8.31, which is not representative, right? Because these are just the smallest numbers. I've only entered the first 8 values, and they were all small, so that's not going to be the right answer. But that's how you would calculate it. And then next is another number that we're going to talk about, it's the standard deviation. And then next is another number that we're going to discuss as well. So that's called the population standard deviation. And then it starts to give me the results for the other variable, which I never put anything in there, so those are not meaningful. Okay, and then it gives me A, B, and R. But you can't get it out of that because there's no other variable. Those are the parameters or the estimates for a line of between two variables, the linear relationship between two variables. So that's it. All I wanted to show you is how to enter it, so you should practice that, maybe with smaller data sets though. And I'll give you examples of that. So that's how you do that. So it's second data to enter the values. You put the number in and then press enter and hit down and put in all the data. Then when you're done, you say second and stat for statistical results, and then you can scroll through the results. So that's just my introduction to that. So you can practice with that, and we will talk about that again when we deal with the standard deviation. Well, you're going to see it in the video, but I should actually show you that in a bit. Let's see how much time we have left. Okay, let's see. Everybody's cool? That is how I will calculate the mean. And it turns out when you calculate the mean of this, now where am I going to get my results? Okay, so in this data set, the sample problems, you see here is the same drawing. So this is in sample problems document, and the solutions come next. So these are the solutions here, and with a nicely stated conclusion. So it turns out, oh, I didn't calculate the mean here. Anyway, the mean will be different. I calculated it somewhere, I believe. Probably the fastest way to get it is through using Excel, and you can see all your mistakes. Well, I guess you can see it on the calculator too. Anyway, I don't have the mean calculated, but they're going to be different, okay? They're going to be different, and just because of how spread out it is, the mean is different than the median, all right? So here we have, the shape is right skewed, like I said. The center will be 20.74. Now I rounded here to 2 decimal places. And then the next thing to talk about, now you notice when you guys gave me answers, some of you guys gave me a range of values because you were identifying the class, or you were just giving me a range of values between classes. So just giving a single number is not, if you have to in a bet, like if you were making a bet on how much the person will spend, you have to give a single value, then you'd have to give a single value and you should give the median. But if you're permitted to give a range of values, you would be giving a spread of numbers, right? So that's our third feature. So let's pick up from there. Let's pick up there. So far we have that the shape is right skewed. The center, the best measure for the center would be the median for a skewed distribution, because the numbers of mean, median, and mode would all be different, and the median would be a nice compromise of those numbers if they are different. So the next feature is the spread. Now the spread also depends on the shape. The spread also depends on the shape. Because there are few extreme values, again, you shouldn't use an estimate or a measure of the spread that is affected by those extreme values, because there's only a few of them, right? So First of all, we're going to mention the range of values. So what's the range of values? The minimum value of the original, right? You go back to the original, was $2.32, and the maximum was $69.49. So let's write that down. So this is equal to, the minimum was $2.32, and the maximum was $69.49. Remembering always to refer to the original data set. And you can also give a calculated range. So if I ask you for a calculated range, or I refer to a single value as a range, you would actually have to give me the difference between the maximum and the minimum. So what would be the difference there? What's the range, the spread of values, in other words? Oh, you guys, you haven't been watching what I've done because it didn't show up. Again, an OBS problem. So here I am. So what I've written here is the spread. I guess you were following along there anyway. So the spread is the range, or the minimum to the maximum interval, or you could calculate the range as the max minus the min. So that would be a range of $67.17. So that's a start. Trying to get this away from this. But we also mention when data are skewed, we also use something called the interquartile range. The interquartile range, or the spread of the middle 50% of data. So basically, there's a pattern, and the regularity of the pattern is in the middle, and the curiosity of the pattern when the data are skewed are on the extremes, right? So here you have, on this side up here, in the high numbers, you have a few observations way up here, but the regular pattern is more in the middle. So let's get a measure of that middle. So what we want to calculate is the interquartile range. And the way that we do that is we first get the 5-number summary. So let's write that. So the 5-number summary. Notice the summary and the 5 features are a little different concepts, but don't get confused. So 5-number summary and the interquartile range will give you your answer. So what's the 5-number summary? What's the interquartile range? The 5-number summary are the 5 quartiles. The 0 percentile, or the minimum. Let's just write the minimum. the first quarter, the second quarter, third quarter, and the max. And I'm going to use curly brackets for that. So this is not hard because we know the min and max and we know the second quarter. What's the second quarter? What's Q2? What do quarters mean? What am I talking about? What's Q1, Q2, Q3? Right, okay. So Q1 is the value such that a quarter, right? What's a quarter? 25% of the observations will be below it or including it. Q2 is the value such that 50% of the observations will be below it or including it. And Q3, they're all capital Q's, is the value such that 75% of the observations will be below it or including it. And then obviously the maximum. So the minimum would be like Q0 with 0% below it, and Q4 would be like 100% below it, or 4 quarters maximum. But that's what we write: Q1, Q2, Q3, minimum, the maximum. So how do you figure out that? This is going to be easy because I've already ranked and ordered all the data over here for you. So we have, here is the min, and you use the original numbers, right? Min, here's the max. So those are done. And we know the median is between median, which is also the 50th percentile, because 50% of the data are below it. So that was 20 point, oh, I want to use my dollar sign, 20.74 or 735. I'll stick with what I wrote on this page, but then I summarize the two later. And sometimes I'm inconsistent with that. Don't worry too much. It's just a convention for reading my notes. Most of the time I use 2 more decimals than the original number as my solutions. Okay, so that's that. So what I've done now, the drawing here gives it away. I've divided the data in half. The median is neither the 25th nor the 26th observation. It's between them. So I can divide the data in half. So now find the median of both halves. The median of the first half would give you Q1, or the 25th percentile, and the median of the second half would give you Q3, or the third quartile, 75th percentile. So how do we find the median of the first half? So n plus 1 divided by 2, right? So it would be, the first half has 25, so it's 26 divided by 2, which is 13th. So the 13th observation is right here. So this is Q2. Are you following? And I guess you can see visually here, this is going to be Q3 over here. No, this is not Q2, this is Q1, sorry. The first quartile. The median is Q2 because it's 2 quarters or 50%. And then Q3 will be this one with the same logic because you're using the same thing. In the second half, it's the same rule. There's 25 There's 25 observations in the second half, so you need to go halfway. So halfway would be at n plus 1 over 2 of the second half, so you're using, again, here n is equal to 25, right? Because there's only 25 observations in each half. So it turns out that Q1 is at the 13th. Also, Q3 is at the 13th of the second half. So that's going to be at 38 or $33.80. Got it? Can you see all that? Questions? So you just count, you'd count 13 from the top, right? You would say 1, 2, no, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. But I can visually see it the way I drew things, that this will be the 13th. Got it? So that's the 5-number summary. So then I write the 5-number summary like this. I put all the numbers in here from the original data, and then I calculate the IQR. Okay, I've gone over my time. You know what I'm going to do is I'm just going to continue because I want to finish this, and if you guys have to go, you guys can go ahead. I'm just going to finish this and you guys can check back. I just want to finish completely the stem and leaf plot, and then you can watch all the rest of the videos that are listed in Moodle. Okay, so I can say goodbye to some of you, but whoever wants to stick around, okay? All right, so I'm going to put these in here. So this is going to be 2.32, 14.35, 20.74. Oh, I didn't put the dollars on it. I should put the dollars on it. 80 and 69.49. And I'm going to put the dollars on it. Dollars and dollars and dollars. So there it is, the 5-number summary. And finally, I'm going to calculate the IQR. IQR is, what is IQR? It's the range of the middle 50% of the data. So that would be the 50% in the middle, because each of those quartiles represents the position of the 25th percentile. That is the position where 25% are below it. So I want the middle, the range of the middle 50%. So that would be the difference of Q3 and Q1. So that turns out to be 3380 minus 1435. Which is 1945. And that's the IQR. So what does that do? That tells you how spread out the middle 50% of data is. So it's spread out by $20 in the middle. Even though the full range is 67, which is, wow, when you think about it, the middle is only 20, spread out by $20. So it's very tight in the middle. That's what it's showing. Okay? Whereas the whole thing is really spread out. So it's showing how spread out the data is, which is exactly the title, spread. So that's going to tell you how spread out the numbers are. And it's useful if you're giving a range of values to remember outside of that range, the data is really spread out with that tail. Any comments from anyone who's still here? How many are you? 17. Okay, so I think that's all I want to say about that. Well, no, I want to say what's the alternative. So we did this because the data was skewed. What if the data wasn't skewed? What would we do? What would be the best measure of spread if the data was not skewed, if it was symmetric? If the data were not skewed, I think that's how I say it. So the data is symmetric, you would use the mean, because it would turn out that the mean, the mode, and the median would be all about the same thing, right? They'd all be around the same number. So it's a convention in statistics just to use the mean, because they're all the same anyways. So they just choose the mean. It's just very common. That's why you think about the average all the time, because that's what everybody uses. But that should only be used when the data that you have has a symmetric shape. So the mean would be the measure of center, and the measure of spread would be another number that uses the mean, known as the standard deviation. So you're going to see, I made some videos about the standard deviation, and you need to watch those. So for symmetric distributions, for spread and center and spread, you'd use mean and standard deviation. So you're going to learn about that if you don't know what that is, but you should really practice that. Okay, so the next feature is number 4, peaks. No, gaps and outliers. Now I have a lot of videos on calculating outliers, but what you need to report right now, because I'm not going to get into it right now, but you're going to have to do it eventually because you're going to read through the sample notes and you can see how it's calculated. These extreme values here draw our attention, okay? They're curiosities of the data. Also, there's a gap before the extreme values appear. So we want to mention that in our report. We want to say there's a gap. There's no data between 55 and 59. So there, there's no data there. And then you want to say that there are possible statistical outliers. Now, I'm here, I'm just typing. So there's possible statistical outliers in 60 to 64 and 65 to 69, right? Because there's a bunch of numbers there. Now they're outliers, like they sit away from most of the majority of the data, or the most of the data. They sit apart from it. So that in that sense they're outliers, but there's an actual technical way to determine if they are, in statistical terms, an outlier, formally an outlier. So you're going to learn how to test for that, okay? And some of them are and some of them not far enough away. In determining far enough, you're going to see what all that means when you watch the videos. And the last point is to mention peaks. And in this case, this is a point of contention, because if you agree with my executive decision to show you 3 peaks, there's 1, 2, 3, then you would say 3 peaks and you would defend it somehow. You'd have to defend why it's 3 peaks. Some people could think some people would draw it instead like maybe some people would think that the data would just smooth out over here and then there's a tail over here. They could think that, if there was all the data, this would just be one big peak and then there would be a few observations over here. They might have drawn it like that. But you have to defend your point. You have to say why you think that is. Now, in this case, I'm going to stick with my decision to show you 3 peaks. And you would mention the peaks by their center, like the mode in each peak. So you would say 15 to 19 for the first one. And then the other one, the mode is 30 to 34. Notice I didn't put my dollar signs. I got to put all the dollar signs in. And then the last one is 60 to 64, right? So those would be my peaks, and I would denote them with the modal class. I'm putting all my dollar signs on. This is my report after all. I have to be consistent, right? The units. So those would be the peaks, and then I could say something, comment, like you have to write a summary to answer the question. And it's all going to be based around using the 5 features to do that. The 5 features that we've written up should provide enough information that someone doesn't even have to look at the graph. They could just read the statistical summary. However, to determine the 5 features, we were dependent on the graph. Okay, so that should be understood. So these 3 could be possibly income classes, like people who spend in the first group, they are low-income earners. In the second group, higher income earners. In the third group, the highest income earners. Okay, could be that. That could be a rationale, and that could provide some information to feed into a second study to look at who are our customers. Okay, we have an idea that there's different classes of customers possibly. Maybe the first set of customers are households, and then the last one with the most spending are actual businesses. Maybe they aren't even individual households; they're actual businesses buying products. So we'd have to target our second project, our second investigation at finding out who those people are. So that's what I want to be able to tell you, so that you can read through the notes and watch all those videos. And essentially, I've answered the first question: how much do shoppers spend in the store? I've shown the 5 features. I've shown that most of the shoppers are spending a lot of them are spending in the modal class here. However, we would report the median to say this is the median spending. You would have to be clear using that expression. And then the spread, the interquartile range is only $20 of spread, right, of the observations. So it would be a median of $20 with a interquartile range of $20, and that it looks like there's 3 classes of shoppers that we need to investigate a little bit more to know who they are, and that we do have some extreme values that are worth investigating, and that's the important thing to say. Okay, so when you have outliers, you first got to test if they're outliers, and then you have to do something about it. Maybe those are just errors, entry errors. Maybe this was really, maybe this was $6. This one was like $6.43. Maybe there's an entry error. You have to check that. But if there's no errors, you have to use the numbers as they are. If there is an error, you can just throw out the numbers. So that's another discussion. So you got to determine if outliers are correct, and then if they are, you have to interpret them and explain them. So the second question, how can the data help improve the store's marketing strategy? Well, just as I said, we need to find out more about who the shoppers are, and we should think about, maybe consider targeting the high spending customers, find out who they are and what products they like, because together those 4 customers are spending as much as everybody before them, right? So that's all I'm going to say for now. You're going to continue with the notes, watch all the videos, and then next week I will answer your questions about this material, okay? Any questions right now? I don't know why you want to see the full page. You don't have the notes? You You should always have the notes with you. What do you need to see? You can take a screenshot. I can send you guys this. I can email this to you if you want. Anyway, it's all in the sample problems, all that stuff, all those calculations. So have a good night, everyone. I'll send this so you'll have it. Good night.